So now we're ready for DESeq. So the DESeq for DESeq we need to input the value in the matrix should be unnormalized counts or estimated counts for sequencing data or for fragments. It's important to provide count matrix as input for DESeq2 statistical model to hold, as only the count values allow accessing the measurement precision correctly. So DESeq2 model internally correct for library size. So transformed or normalized values such as count scale by library size should not be used. And the DESeq data size object will must have an associated design formula. So the design formula expresses the variable which will be which will be used in modeling. The formula should be a tilde followed by the variable with plus signs between them. So for example, we can see it like right here. However, here I'm only using condition, but if you have other variables, you can also add a plus signs to separate these two variables. For example, if we have batch tilde batch plus condition, the design will indicate how the model how to model the samples, and we want to, and if the DESeq dataset is going to measure the effect of the condition controlling for the sample for the batch differences. So this function only this function is going to show you the effect of the last variable, and the previous variables that you put in is just going to be controlling factors. So firstly, yeah, let's start from back to here. I'm just importing some of this data, and we can see here there are two in the condition column. There are two conditions, which is the A and the B. And then I prepare for the DESeq dataset. And we want to see the effect of the condition, and then I do the DESeq. And the result table will be generated using the function results, which extracts result table with log2 fold change, p-value, and adjusted p-value. With no additional argument to result, the log2 fold change and p-value will be for the last variable of the design formula. And if this is a factor, the comparison will be the last level of the variable over the reference level. So in our case, the B versus A, which is because A is at the front and B is later. So B versus A, as saying here. Yeah, and if this is batch plus condition, that will be condition effect with batch controlling. If that's condition plus batch, then it's batch effect conditional on controlling on condition. So yeah, it's really important to figure out like to the order passing here is really important. And then we do a log4 change shrink for visualization and ranking. So the shrinkage of the effect size is useful for visualization and ranking of genes. To shrink the log4 change, we pass the DDS object to the function LFC shrink. And we specify to use the apoglim method for effect size shrinkage. So there are different methods, but I think this one, this one is the most commonly used one. I don't really know so much about the different methods. If you guys are interested, you can just Google them yourselves. I have been using this myself, so I don't really know there's other stuff. And then if you want to show like how this is distributed, we can do this plot MA, and we can see there are some we can see the log4 log fold change, some of the genes has log fold change greater than 1. Yeah, and this can provide us this information. Sometimes you can even label. You can also adjust for the axis. So maybe you can see here there are some of the genes maybe further away, as more than log fold change 3. You can change this to -5 to 5, so you can see the whole picture. And sometimes you can even label the gene names of these genes that's has really different log fold change. You can also do a volcano plot, which is like this one, and this is called the enhanced volcano. So it's a different one from the previous year that I was using. That you need to specify all these factors to see which one you want to have the label to. But this one is much easier. You just need to pass in some of these values, which is not majorly just the peak cutoff and the log fold change cutoff are the ones that you're mostly interested, the thing that you want to specify. And if you want to, you have a set of genes that you're specifically interested in, you can just plot, like here, plot all these genes that you're interested to see where these genes are located in this volcano plot. So the volcano plot showing like the p-value and log two-fold change that passes the cutoff you have, and those that's only passing for the p-value is in blue here, and those that only passing the cutoff for the log fold change is showing in green, and those that's not significant is like gray. So this is even a better way than the standard volcano plot. Or if you're interested in the standard volcano plot, you can also take a look of it. Maybe you can you have some more freedom over that plot. Yeah.